Welcome to the deep dive. We're jumping straight into, well, a core challenge in the software world, really. Planning.
Yep, planning. Always tricky.
Especially agile planning, right?
Yeah.
Keeping things organized, moving forward, but staying flexible enough for, well, for reality.
Yeah, all the surprises, yeah.
So our listeners shared some really detailed course notes on this, and our mission here is to pull out the absolute essentials, the actionable stuff.
Think of it as your fast track, getting you up to speed on what really counts.
Exactly. More than just definitions. We want you to get a real feel for the core ideas, dealing with uncertainty, handling risk.
Which can absolutely derail things if you're not careful.
For sure. And we'll focus on three key areas from these notes. First up, release planning, that longer view.
Right, the bigger picture.
Then iteration planning. That's more like the day-to-day, sprint-by-sprint stuff.
Where the rubber really meets the road.
And finally, risk planning. Because, let's face it, knowing what might go wrong is half the battle, isn't it?
Yeah, absolutely. The notes actually break it down nicely. Module 1 is the basics, planning concepts. Module 2 gets into estimation, release plans.
Okay.
Module 3 covers more on time estimates, dependencies, iteration plans. And then Module 4 is all about risk.
Got it. So let's jump in.
The interesting thing about good agile planning, it's not about some rigid, fixed blueprint you follow religiously.
No, that wouldn't be very agile, would it?
Exactly. It's smarter. You break down the big project into smaller, digestible pieces, and critically, you think about risks at every single step, not just at the end.
Okay, let's unpack Module 1 then. Introduction to planning. The notes stress why planning is still so vital in Agile. It's not just schedules, right? It has to be adaptable.
Totally. Traditional planning often aimed for that fixed upfront thing. Agile planning knows change happens. It's inevitable in software.
So the plan is more like a guide.
Yeah, a guide that sets direction, organizes work, estimates effort and time, but crucially, with the understanding that you'll learn and adjust. You need schedules for the release, for iterations, sure, but you're also building in risk planning constantly.
Right. And to really get this, we need the language, key terms. What are the absolute must-knows from the notes?
Okay, the notes list a few basics. The task, just a small, actionable step.
Simple enough.
A role that's the hat someone wears. Programmer, tester, designer, product manager, even the client has a role.
Right.
A work product is the output, the thing you get from a task.
Like a piece of code or a document.
Exactly. The schedule maps tasks to a timeline. And milestones. Well, they're internal checkpoints. But the notes point out an agile working software is the real measure of progress, so milestones are less of a focus.
Makes sense. Continuous value delivery, not just hitting dates. How did these terms connect? It's a system, isn't it?
Definitely. Roles do tasks. Tasks create or use work products. Tasks form the schedule. And understanding the dependencies is vital.
Dependencies, meaning what needs to happen before something else can start.
Precisely. If task A creates something task B needs, task A has to come first. Obvious, maybe, but critical for prioritizing and planning iterations. You need to know what can be done.
Okay, got it. Now this concept, uncertainty space, sounds a bit sci-fi. What's the idea there?
Huh. Yeah, it does a bit, but it's a really useful way to think about the unknowns. It splits uncertainty into two types.
Okay.
There's ends uncertainty, that's about what you're building, the features, the functionality, and Z means uncertainty, that's how you'll build it, the tech, the process.
And the diagram plots these.
Yep. Means uncertainty on the x-axis, ends on the a-axis, high to low on both.
So start of a project, you're probably high on both. Lots of questions about the what and the how.
Exactly. Top right corner. Ideally, as you progress, you move towards the bottom left, clear product vision, clear development approach.
How do you navigate that space? The notes mention 3 ways.
Yeah. First way. Nail down the what completely, then figure out the how. Very waterfall-like. But, like the notes say, it's not very adaptable if your initial what was wrong.
Right. Hard to change course later. What's the second way?
Figure out the how first, then, kind of. Make it up as you go along. The notes call it ad hoc. It's risky.
Because you might build something brilliantly that nobody actually needs.
Precisely. You're great with this tool, so you build something hoping it fits. Big risk of wasted effort.
Okay, so what's the third, the better way?
The agile way, really.
Right.
Balance both. Iteratively figure out the what while you figure out the how. Much more adaptable, much less risk of major rework.
And uncertainty doesn't always just decrease smoothly.
Good point. No, requirements change, right? So you might see temporary spikes in uncertainty, but the overall trend should be downwards for both.
That uncertainty space really highlights why Agile's flexibility is so important. Okay, work breakdown structure, WBS. This sounds like a practical tool for making ideas tangible.
It really is. A WBS is basically a visual chart, hierarchical. You break down the entire project scope into smaller, manageable bits of work, task work products, the notes call them,
Keep breaking it down into.
until each task is really clear enough to assign to one person. Importantly, the WBS itself doesn't show dates or order, just the breakdown of work.
So it's like dissecting the final product into components, then subcomponents down to individual actions.
Exactly. The notes say you can organize it functionally, all programming together, all testing together, or by phase, like initiation, development, testing, implementation.
Is there an example?
Yeah. The news application
Yeah.
shows product at the top, breaking down to programming, documentation, then further down to links, buttons, layout, widgets, eventually getting to actual tasks like source code, unit tests, acceptance tests.
That makes it very clear. From big idea to small tasks. And the notes mention SMART criteria, like a checklist.
Yeah, SMART ensures tasks are well-defined, specific, measurable, achievable, relevant, and time-boxed. Helps make sure each task is clear, doable, contributes to the goal, and has a time frame.
And the 100% rule.
Simple but important. The WBS has to cover 100% of the defined project scope. No more, no less. Keeps things focused.
So why bother creating a WBS? What are the payoffs?
Several key benefits, according to the notes. 1, it helps you identify all the actual tasks. 2, it makes estimating timelines easier because you estimate the small pieces and add them up.
Okay.
3, it can flag potential risks tied to specific work products. And 4, it's a great way to visually show the scope to clients. Makes it understandable.
Makes sense. Okay, final bit of Module 1. Estimates, targets, commitments. These sound easily confused. Getting them straight seems crucial.
Oh, absolutely. Confusing these causes a lot of problems. The notes clarify them well. An estimate is your best guess on time or effort, ideally based on clear tasks, input from the people doing the work.
Often a range, right? To show uncertainty.
Yes, often ranges. And crucially, estimates should be non-negotiable in the sense that they reflect the team's professional judgment, not wishful thinking or pressure.
So if the team estimates 2 weeks, that's their professional judgment based on what they know.
Exactly. Now, a target is a specific date on the schedule, often external, like a sprint end or release date. Targets are often non-negotiable too, maybe contractual.
Launch by end of Q4, that's a target.
Right. And then there are commitments. This is what the team agrees to deliver within a time frame. This is where negotiation happens.
Based on the estimates and the targets.
Precisely. Given the estimates and the targets, what can the team realistically commit to? The notes have that example. 1,000-hour estimate, 600-hour target. Maybe you commit to delivering a reduced scope that fits in, say, 500 hours of effort.
So you negotiate the scope to fit the constraints based on the realistic estimates.
Exactly. And the notes warned strongly against just automatically making estimates into commitments or targets. That just pressures developers to inflate estimates up front to protect themselves.
Yeah, I can see that happening. You need clear distinctions and honest conversations.
Absolutely. It's key for managing expectations and having a collaborative environment.
Okay, that's a solid foundation. Module 1 sets the stage nicely for Module 2, estimation. Kicking off with story points, these always felt a bit like Agile magic currency or something. What are they really? Why not just use hours?
Huh. Yeah, they can seem that way. They really came about because time estimates get mistaken for commitments so easily. So instead of saying, this takes 8 hours, you assign it story points. It's unitless, purely relative.
Relative, that's the key word. So a 5-point story isn't 5 hours, it's roughly 5 times the effort of a 1-point story.
Exactly, that's the core idea. The notes explain you pick a small, well-understood user story from the backlog. We've covered user stories before, assign it a base value, maybe 1 or 2 points.
Okay, your baseline.
Then you estimate all other stories based on complexity, risk, effort relative to that baseline. If something feels twice as hard, it gets roughly twice the points. It abstracts away from time.
So sizing work relative to other work, not predicting absolute duration. And the notes recommend Fibonacci numbers. 1, 2, 3, 5, 8. Why that specific sequence?
It's quite practical, actually. It gives you fixed values, but the gaps get bigger as the numbers rise.
Right. 8 to 13 is a bigger jump than 2 to 3.
Exactly. The idea is you round your estimate up to the nearest Fibonacci number. It avoids fake precision, especially with bigger, more uncertain items. That jump from, say, feeling like a 9 to assigning a 13 acknowledges there's more uncertainty baked in.
Interesting. Builds in some fuzziness.
Yeah.
What are the big advantages then?
The main one, as the notes highlight, is fewer unintended commitments based on time. People are also often better at relative sizing. Think of comparing building heights, easier to say that one's twice as tall than guess the exact meters for both.
Good analogy.
And it can be less stressful for developers, shifting focus from rigid time promises.
Sounds good. Any downsides? Limitations?
Yeah, a few. It needs a mindset shift away from time.
Mm-hmm.
There's always a temptation to mentally convert points back to hours anyway.
I can imagine.
Estimation is still estimation, right? It can be wrong. And on big teams, you could get story point inflation, assigning higher points just to look busy. But consistency and clear team guidelines help prevent that.
Okay, so relative effort helps avoid time commitments, but needs consistent team understanding. Next, velocity estimates. This sounds linked to story points.
It is directly. Velocity is just how much work, measured in story points, a team typically gets done in one sprint.
So the total points for all the user stories they fully completed.
Exactly. Fully completed is key. It becomes a really useful metric for forecasting. If a team usually completes 30 points per sprint, you can predict roughly how much they'll likely do in future sprints. Helps with planning.
So if their velocity is 30, you wouldn't try and cram 50 points into the next sprint plan.
Ideally not. And the note stress using story points for velocity is usually better than just counting stories, because stories vary so much in size. Pick one metric and stick with it. And again, only points for stories that are truly done count.
And done in Agile means more than just coded, right?
Oh yeah, the notes mention done in Scrum. It means coded, unit tested, acceptance tested, documented, all of it. Only then do the points count towards velocity.
Right. No credit for half-finished work. So how do teams use velocity for planning?
That's velocity-driven development. You look at your historical velocity, maybe average the last few sprints to smooth things out. Then, when planning the next sprint, you pull user stories from the backlog until their total story points are around or just under that historical velocity.
Gives you a realistic target for the sprint. But what about the very start of a project? No history yet.
Good question. The notes suggest a few ways. Talk to experts, look at the team's past experience on other projects, maybe even make an educated guess for the first sprint or two, and then adjust based on actuals.
So you can use techniques like averaging the last 3 sprints, or maybe take the minimum of the last 3 if you want to be cautious.
Exactly. It's a tool for long-term planning, seeing trends, but it's based on the past, so yeah, not a perfect crystal ball. Still, sounds way better than just guessing randomly how much fits in a sprint. Okay, time boxing. We mentioned sprints are time boxes. Can you expand on that concept?
Sure. Time boxing is simply setting a strict, fixed time limit for something. A piece of work, a meeting, an entire sprint. The fixed time frame is the crucial part.
Non-extendable.
Right. Sprints are the classic example in Scrum, usually 1 to 4 weeks. You plan the work for that box, you do the work, and you reflect at the end, all within that fixed time.
What are the benefits of working this way?
Several. It keeps things on track, prevents work from endlessly expanding, it promotes a sustainable pace. You're not sprinting forever just for the duration of the time box.
Breaks big projects into manageable chunks.
Exactly. Yeah. Clarifies goals for that period, improves efficiency by creating focus. And those built-in review periods are vital for learning and adapting.
And velocity helps you avoid stuffing too much into the box.
Absolutely. You use velocity to gauge how much work realistically fits. Overfilling a time box is usually counterproductive, leads to rushing, lower quality burnout. Makes sense. And the goal is working software at the end of each time box.
Yes, that's key. It allows for staged releases, gets feedback flowing, and gives the team regular, tangible accomplishments. Good for morale.
Okay, shifting gears a bit. Gantt charts. These feel very traditional project management. Do they have a place in Agile?
It's a fair question. Gantt charts are those horizontal bar charts, right? Tasks on the left, timeline on top, bars showing duration, often used in waterfall.
Yeah, showing dependencies, deadlines.
They can still be useful in Agile, but you have to use them the right way. The notes suggest using them maybe for a high-level overview.
How so?
You'd add context, show dependencies clearly, maybe visually block out the sprints on the timeline. But critically, it has to be flexible, a living document, not set in stone.
So not the primary planning tool, perhaps, but maybe for visualizing a release plan across sprints, or even tasks within a sprint.
Exactly. You can use them at both release level, user stories across sprints, and iteration level, tasks within a sprint. Arrows can show dependencies, though the notes mention CPM and Purity charts are often better for complex dependency mapping. It's about providing a visual roadmap, but one that can change.
Got it. Adapting a traditional tool. Finally, in Module 2, Release plans. This sounds like the bridge between the big vision and the sprint-by-sprint work.
That's a perfect way to put it. The notes talk about two levels of planning: iteration planning, detailed tasks in a sprint, and release planning, broader user stories across multiple sprints. Both use time boxing via sprints.
So release planning looks further ahead.
Yeah, a few sprints ahead usually. You take your prioritized backlog and decide which user stories you'll target for which upcoming sprint. This happens before you do the detailed planning for each individual sprint.
How do you decide how many stories fit in each future sprint? Still based on velocity.
Yep. You use past velocity and story points. Maybe you categorize stories must have, should have, could have. Then you allocate them to sprints based on priority, adding stories until the total points get close to your projected velocity for that sprint.
So it gives you a forecast. Like after these next 3 sprints, we expect to have features A, B, and C delivered.
Exactly. It provides that projection, which is crucial for managing stakeholder expectations. And it helps the dev team see the bigger picture too, which is good for morale. The notes also mention creating an even longer-term roadmap sometimes.
Okay, giving everyone that sense of direction without overcommitting too far out makes sense. Let's move to Module 3, Planning. Diving deeper into estimating time and dependencies. It starts by revisiting the cone of uncertainty principle. Why bring this up again now?
Because it's fundamental when you start estimating individual task times. Remember, uncertainty is high at the start, lower later on. The cone visualizes how the accuracy of your estimates improves over time.
Right, so early estimates have a much wider potential range than later ones.
Precisely. At the very beginning, product definition stage, the variability is huge. Your estimate could be off by a factor of 2, 3, even 4, high or low. As you move through requirements, architecture, detailed design, that variability narrows, the cone gets tighter.
And the notes show how to use this to create estimate ranges, not just single numbers.
Yeah, exactly. You take your best guess estimate, then multiply it by the variability factors for your current project stage from the cone. The example, 6-hour estimate during requirements elicitation, where variability might be 0.5 to 2.
So the realistic range is actually 3 hours to 12 hours, 6 by 0.5 to 6 by 2.
Exactly. It really drives home how uncertain those early estimates are and why you need to keep refining them as you learn more and the cone narrows.
Very practical. Okay, creating time estimates. The notes stress being data-driven and estimates being non-negotiable reflections of judgment. What methods are covered?
4 main approaches. First, bottom-up. You break the project into small tasks using WBS, estimate each small task, then add them all up. Good for quick estimates if you have enough detail.
Building the estimate from the individual pieces. Makes sense.
Second, estimation by analogy. Compare the current task or project to similar past ones. Same team, similar scope, tech, etc. But you have to be careful it's a truly similar past experience.
Right, can't compare apples and oranges. What's third?
Using experts. Get estimates from multiple experienced people, especially if the team lacks experience in that specific area. Converge on an estimate can be costly, but potentially very accurate.
Leveraging collective wisdom. And the last one, the Peart 3-point estimate formula. Sounds more formal.
It is. Peart's a statistical method. You estimate 3 values for a task. Most probable time, T, the realistic guess, optimistic time, 2, best case, and pessimistic time, TP, worst case.
Okay, best, worst, and most likely.
Then you calculate the expected time, T, using the formula. 2 plus 14 meter plus TP, 6. Notice team gets weighted more heavily.
Right, the most probable scenario counts more. Does it give a range too?
Yes. You calculate the standard deviation, SAT measures the spread. Then TMS gives you about a 68% confidence range. T-bond 2 gives about 95%.
So it quantifies the uncertainty around the estimate.
Exactly. The notes also mention an alternative triangular distribution formula, TM on 2 plus TMM plus TP3, which weights them equally. The key is thinking beyond one number and acknowledging the uncertainty.
Gives a much richer picture. Okay, tasks rarely happen in isolation. Task dependencies. Why is understanding these so critical for planning?
Because they dictate the order. A dependency means one task's start or finish relies on another's start or finish. If you don't account for them, your schedule is just fantasy. It won't work.
Makes sense. The notes list 4 types. Let's quickly run through them. Start.
Means task A must start before task B can start. They might run in parallel after that. Example, start developing a feature, then you can start writing its glossary entries.
Okay, task A kicks off task B. Start-finish. Sounds counterintuitive.
A bit less common. Task A must start before task B can finish. Often involves handovers. Example, starting planning for the next sprint before the current sprint finishes.
Got it. Ensures continuity. finish start. This seems like the most common one.
It is. Task A must finish completely before task B can begin. Classic example. Design a UI before you start coding it.
Simple sequence.
Hmm.
And finally, finish.
Task A must finish before task B can finish. They might run in parallel, but B can't wrap up until A is done. Example, finalizing billing before you finalize the product handover.
Okay, clear. These dependencies create a network, which leads us to critical path method CPM charts. How do these help visualize this network?
CPM charts are a great visual tool for organizing tasks, showing dependencies, and figuring out the minimum project duration. The notes give 5 steps to create one.
Okay, step 1.
List all tasks, maybe from a WBS. Step 2, add time estimates to each task. Step 3, arrange tasks visually, horizontally, showing dependencies with arrows.
Like the spaghetti dinner example in the notes, showing tasks for pasta, meatballs, salad.
Exactly. Step 4 is identify the paths sequences of tasks following the arrows from start to finish. Where paths meet is a coordination point, everything before it must be done. The longest path determines the overall project time.
And step 5 is just combining all paths into the full chart.
Right. Then you find the critical path. That's the longest duration path through the whole chart. It's critical because any delay on that path delays the entire project.
And tasks not on the critical path have slack, some buffer time.
Exactly. Slack is the amount of time a non-critical task can be delayed without affecting the project end date. CPM helps you see where the bottlenecks are, the critical path, and where you have flexibility, slack.
And the CPM time estimate might differ from just summing WBS tasks.
Yeah, because CPM accounts for parallelism allowed by dependencies, while a simple WBS sum often assumes sequential work.
Very useful. Now, the notes also cover program evaluation and review technique, PIT charts. How are these different from CPM?
PERT is another visual tool for dependencies and timelines. It uses nodes, circles or boxes, for milestones or events, points in time, not durations. And edges, lines connecting nodes, represent the actual tasks, labeled with time estimates and arrows for dependency.
So nodes are milestones, edges are the work between them.
Pretty much. Multiple edges from a node mean parallel tasks. Multiple arrows into a node mean synchronization. All those tasks must finish first.
The spaghetti example is used again here, showing paths for pasta, meatballs, salad, then combined.
Yes, showing nodes as numbered milestones and edges labeled with tasks and times. PERT also has a critical path, the longest time path through the nodes and edges, representing the minimum project time.
And Slack works similarly. Tasks off the critical path have buffer time.
Yes, and the notes mention a convention. The critical path in PERT is often drawn horizontally for easy spotting.
So CPM versus peer, when use which?
Both are good for dependencies and time estimates. Notes say preference can be personal. CPM might be better if you're very task-focused and want to add costs to tasks. PEAT might be better if you're more event milestone-focused, clearly showing predecessors to events.
Okay, good guidelines. We've covered release plans, multiple sprints. The last topic in Module 3 is iteration plans. This is about planning within a single sprint.
Exactly. Iteration plans manage the tasks for one specific sprint, based on velocity, estimates, available time. Goal is to avoid over or under committing for that sprint. Core part of Scrum XP.
And these are made in the sprint planning meeting, which is time-boxed.
Yep, sprint planning is usually time-boxed, maybe 4 hours for a 2-week sprint. Keeps it focused. The notes list 6 steps for creating the iteration plan.
Step 1.
Define a sprint goal if the release plan doesn't have one. Gives focus. Step 2, report the previous sprint's velocity to gauge capacity. Maybe use the lowest recent one if the last was weird.
Okay, capacity check. Step 3.
Select user stories from the backlog for the sprint. Based on the release plan, maybe carryovers. Then, the developers break these stories into tasks. Small tasks, like a day or 2 max, total story points should be velocity.
So pull in work based on capacity, then break it down. Step 4.
Developers estimate each task in hours, half days, whatever. Agreed by the whole team. Small tasks get combined, big ones, over 3 days, get broken down further.
Step 5.
Revisit the chosen stories after task estimates. Does it still look feasible? Adjust scope if needed, remove stories tasks, or add more if there's capacity.
Final check. And step 6.
Task self-assignment. Team members volunteer for tasks based on skills, availability. Leads to more ownership, satisfaction.
So the iteration plan gives that clear, shared understanding for the sprint, keeps everyone aligned. Okay, Module 4. Risks. Crucial stuff. Even great plans hit bumps. Starts with anti-patterns. What are these in this context?
Anti-patterns are basically common traps. Recurring solutions or situations that seem okay but actually cause problems. Here we're talking management anti-patterned ways projects fail due to how people behave or make decisions.
Gotcha. Common pitfalls. The notes split them into group and individual. Let's start with group anti-patterns first. Analysis paralysis. Sounds like getting stuck planning forever.
That's exactly it. Overanalyzing requirements so much that you delay actually starting the work. The fix. Incremental releases. Deliver fast, learn as you go. Don't try to perfect everything up front.
Lean principle, right?
Okay.
Cart before the horse.
Focusing too much effort on a less critical part of the project that should come later, like polishing minor features before the core stuff works. Solution. Understand priorities. Focus on core value first.
Eliminate waste. Next, groupthink. We hear this term a lot.
Yeah, it's when people conform to the majority opinion without critical thinking, even if they disagree privately, leads to bad decisions. Counteract it by encouraging open debate, diverse views, maybe silent brainstorming first.
Creating psychological safety. What about silos?
Lack of communication between different teams or groups on the same project leads to incompatible work, duplicated effort. Fix is fostering open communication, collaboration, maybe flatter structures, face-to-face interaction.
Breaking down walls. Vendor lock-in.
Becoming too dependent on one specific technology or vendor limits flexibility, makes switching costly later. Avoid it by doing thorough research before committing. Consider the long term.
Strategic thinking.
Well,
Over-engineering.
making things more complex than needed. Adding confusing extra features or overly complicated tech solutions. Avoid it by clearly understanding user needs versus wants. Keep it simple.
Focus on requirements. Similar vein. Gold plating.
Adding extra stuff, often unwanted by the client, just to impress them or because developers think it's cool. Diminishing returns. Solution. Stop when it works well. Vet any new feature ideas with the client. Does it actually improve things?
Builds what's needed, not just what's possible. View graph engineering. Sounds bureaucratic.
Huh. It is. Spending way too much time on fancy reports, docs, presentations, instead of actually building the software. Common in hierarchical orgs. Solution. Focus on working software, prototypes over excessive documentation.
Value working software. Fire drills. Heroics. Last-minute crunches.
Yep. Relying on intense overtime and individual heroes to meet deadlines, usually caused by bad planning, wasted time, poor expectations. Solution. Set expectations early, use time boxes, produce working software regularly for a steady pace.
Sustainable pace. Last group one. Death march. Sounds dire.
It is. When development and management are totally at odds about the project direction or feasibility, leads to low morale, burnout, people leaving, often due to finances or stubbornness. Solution. Open communication. Listen to the team, be willing to explore alternatives.
Keep the team alive and engaged.
Okay.
Individual anti-patterns. First, micromanagement.
Excessive control over every detail shows lack of trust, often from the manager's own stress or insecurity. Fix requires the manager to recognize it and change. Leads delegation, trust. Different from healthy progress checks, obviously.
Empower the team. Seagull management. Intriguing name.
Manager swoops in only when there's trouble or a deadline, dumps info or criticism, then flies away again, often due to being overloaded, poor planning. Manager needs to reevaluate their interaction style, be more present.
Insistent support, not just flybys. Email as a primary means of communication. Seems normal now.
It can be too normal. Relying only on email can lead to misunderstandings, lack of nuance, even enable seagull management. Prioritize richer communication, face-to-face, chat, video calls, phone. Shows respect, improves clarity.
Choose the right tool for the job. Loose cannon.
Someone who makes big decisions without consulting the team. Unpredictable, causes rework, increases risk. Need to understand why, encourage collaboration, maybe organizational steps if it persists. Address it quickly.
Teamwork makes the dream work. Finally, intellectual violence. Sounds nasty.
It is. Using knowledge to intimidate, questioning everything aggressively, asserting opinions forcefully, creates fear, kills morale, shuts down contribution. Manager needs to talk to the person privately, encourage respectful debate, stop prejudging. Address it fast.
Foster respect and safety. Recognizing these anti-patterns is key to avoiding them. Now, beyond behaviors, other causes of failures, specific risks.
Right. Risk is anything that could cause failure. The notes list types. Scope risks requirements creep. Agile handles this better than waterfall. Technology risks hardware fails. Software obsolete. Can't scale. Team doesn't understand it.
Yeah.
Customer and stakeholder risks late info, apathy, contact person changes. Personnel risks, key people leave, skills gaps, team conflict, communication issues, like groupthink.
People are risky.
Yeah. And other risks, legal stuff, security breaches, physical disasters, market loses interest, even espionage. Lots can go wrong.
Okay, scary list. So how do we deal with them proactively? Risk assessment, likelihood, and impact.
After identifying risks, you assess two things. Likelihood, how probable is it? And impact, how bad if it happens. A great tool is the impact versus likelihood matrix.
The 2x2 grid.
Exactly. Impact low to high on one axis, likelihood low to high on the other. You plot each risk. High impact high likelihood risks are top priority.
So you rank them, like high, medium, low risk.
Yep. The matrix zones tell you the rank. High risks need immediate mitigation plans. Medium risks need contingency plans, concern. Low risks need monitoring. The notes use funding versus asteroid examples to show placement.
Helps focus your energy. What about the risk-value matrix? Similar idea.
Similar grid, but for prioritizing features, not general risks. Risk of developing the feature on one axis, business value on the other.
So you assess features based on risk versus reward.
Exactly. The principle. Tackle high-risk, high-value features first. Address the biggest threats and deliver the most value early. Notes compare database risk versus UI risk value.
Smart prioritization. Okay, finally, risk strategies, contingency, mitigation, planning the response.
Yes. Create a risk management plan, often a table. Risk description, risk ranking from the matrix, indicators, warning signs it's happening, and action to take, mitigation or contingency.
So for each major risk, you know what to look for and what to do.
Ideally, yes. The notes give an example. Risk of not getting music copyright. Ranking 2, indicators, stalled communication, actions. Incremental delivery, secure funds, maybe PM gets involved.
Very practical. Focus on the high and medium risks.
Definitely. Planning for those really ups your chances of success. But, unforeseen stuff will still happen. Product managers need skills to handle those unknowns in the moment, too.
So plan for the knowns. Be ready for the unknowns. It's a mix of proactive planning and adaptive response. Wow, that was a comprehensive dive into agile planning.
We covered a lot of ground.
Absolutely. From uncertainty and key terms, through estimation like story points and velocity, managing dependencies with CPM and PEERT, right up to identifying and planning for risks and anti-patterns.
It really shows that agile planning isn't rigid. It's about having direction, but embracing change and managing obstacles thoughtfully.
Exactly. And hopefully this deep dive gave you, our listener, that accelerated understanding, those aha moments, without getting totally swamped in details.
Yeah, the key takeaways to make you better informed.
So as you think about all this, here's something to chew on. How might that balance, the balance between detailed upfront planning and continuous, flexible adaptation? How might that balance ideally shift depending on the project? Think about project size, complexity, how stable the requirements are, the team's experience level.
Right. When would you lean more towards structure versus more towards emergence?
What are the pros and cons of leaning too far one way or the other in different situations? Something to ponder. Thanks for joining us on this deep dive.